Hey there, everyone! Welcome back to our channel. I'm so glad you decided to join us today. If you're interested in the intersection of technology and privacy, you're in the right place. Today, we're diving into a fascinating topic that's becoming increasingly important in our digital world: differential privacy in AI. So, grab a snack, get comfy, and let's get started. But first, let's ask ourselves a pivotal question: why is privacy so important when it comes to artificial intelligence? After all, AI relies on data to learn and make predictions. What if I told you that there's a way to harness the power of data while still protecting individuals' privacy? That, my friends, is where differential privacy comes into play. Alright, let's break it down. Differential privacy is a technique used to ensure that the output of an algorithm does not compromise the privacy of any individual in a data set. In simpler terms, it allows organizations to learn from data without exposing sensitive information about anyone involved. Imagine you have a database of medical records. If a researcher wants to analyze this data to find trends in treatments or diseases, they could inadvertently expose sensitive information about specific patients. With differential privacy, the researcher can still gain insights without being able to reconstruct the identity of any individual patient. So, how does it work? At its core, differential privacy introduces a controlled amount of randomness into the data. By doing so, it masks the presence or absence of any individual's data, making it nearly impossible to identify specific individuals based on the results provided by the algorithm. Let's illustrate this with an example. Suppose a company wants to share data about users' exercise habits but doesn't want anyone to be able to identify individual users. Using differential privacy, the company could add random noise to the data before analysis. This means that if my exercise data is included, the company might show that on average, users exercise 3 times a week without revealing that I exercise 4 times a week. This concept isn't just theoretical, it's being implemented in real-world applications. For instance, tech giants like Apple and Google have adopted differential privacy in their products. Apple uses it to enhance user experience while safeguarding privacy in features like location services and health tracking. Google, on the other hand, employs it in its data collection practices for services like web analytics to improve user experience without compromising individual user information. Now, let's look at some numbers to understand just how impactful differential privacy can be. A study conducted by researchers at the University of California, Berkeley, found that differential privacy techniques could allow companies to analyze data without sacrificing user privacy. In their experiments, they were able to provide accurate statistical insights, preserving the privacy of individual contributions while still offering valuable information to researchers and businesses. However, it's important to note that differential privacy isn't a one-size-fits-all solution. There are several factors to consider, such as the level of privacy required, the sensitivity of the data, and the potential impact of the noise added to the data set. The balance between privacy and utility is crucial. Too much noise can render the data useless for analysis, while too little may expose sensitive information. Another interesting aspect of differential privacy is its mathematical foundation. Differential privacy is defined using a concept called epsilon, a parameter that measures the privacy loss. A smaller epsilon value indicates a higher level of privacy, but it also means more noise is added, which may affect the accuracy of the results. Researchers are constantly working to optimize these parameters, ensuring that we can achieve the best of both worlds, privacy and data utility. Moreover, differential privacy has implications beyond just data analysis. It's influencing regulations and policies surrounding data privacy. As concerns about data breaches and misuse grow, organizations are increasingly required to adopt practices that protect user data. Differential privacy is emerging as a leading approach in this space, helping to shape the future of data governance. To wrap it all up, differential privacy is a powerful tool in the world of artificial intelligence and data analysis. It allows us to extract valuable insights from data while respecting and protecting individual privacy. As we continue to navigate the digital landscape, understanding concepts like differential privacy will be crucial for both consumers and organizations. So, what can you do? Stay informed. Knowledge is power. Whether you're a tech enthusiast, a researcher, or simply someone who cares about privacy, understanding the implications of differential privacy can help you make informed decisions. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you never miss an update from us. And feel free to leave a comment below. What are your thoughts on differential privacy? Do you think it can help us strike a balance between innovation and privacy? Let's chat. Thanks for watching, and see you next time.